Okay, we're going to finish up our discussion on arithmetic sequences here today. As we talked about going from recursive formulas to explicit formulas in the past couple of days, we've come to realize that explicit formulas are a little bit easier to deal with, especially if we have to find a term in the sequence that's pretty far out there. Now, we can continue to use recursive formula if we're talking about finding like one of the first couple terms of a sequence. But if we're talking about finding like the 25th term of a sequence, it's going to be kind of time consuming to use recursive formulas. So, as a little bit of a review from yesterday, we have that lovely explicit formula, which tells us to find a certain term in the sequence, we must take the first term in that sequence, add it to n minus 1, which n stands for the number term in the sequence, times the common difference d. Okay? So in our examples today, what we're going to be looking to do is we're going to be looking to take a recursive formula and transform it into an explicit formula. Now, in order to do that, up to this point, when we talk about explicit formula, we've been talking about finding and, a sub 1, n, and d. Now, we're looking at creating the formula here, not looking at finding a specific term. So we won't know what n is in this given example. Everything else we can find. A sub 1 in this given example is 7. D, the common difference, is what we're doing every single time going from one term to the next, and here we're adding 6. But nowhere in the instructions or in this problem does it say what term to find. So we're going to go ahead and leave that as what we don't know. We can leave it as n. So what we need to do is plug in the values that we do know into our explicit formula, simplify, and we will have an explicit formula converted from the previous recursive formula. So a sub n is equal to the first term in the sequence, which is 7, plus in parentheses n minus 1, since we still don't know what n is, we're going to leave those n's alone, times the common difference, 6. Okay, so now if we were left with something like this, we would normally need to distribute the 6 and combine like terms. We are going to go ahead and do that here. So when we distribute, we're going to end up with 7 plus 6 times n, variable times a number, just push them together, and 6 times negative 1 is a negative 6. Now we want to combine like terms, combine all terms that have an n. Only one of the three have an n, so we're going to go ahead and write it out front. Leaves us with 7 minus 6, which gives us a positive 1. That is our explicit formula from a recursive formula. Now, if they asked the second part of this question, they told us to find the 20th term of the sequence. We could simply plug in 20. Hold on one second.
Mr. Steamer, if you're still in the building, please contact Mrs. Boggs. Thank you.
If we were looking for the 20th term in this sequence, we need to plug 20 in here for n. We have 20 times 6 to give us the 120. Add 1 to that to give us 121. So this is definitely simpler than adding 6 each time. So that means a sub 1 is 7, a sub 2 is 13, a sub 3 is 19, and keep on going from that process. A lot quicker here. So let's go ahead and you want to pause the video and try this one on your own. You can. All right, this one's a sub n is equal to a sub n minus 1. We're going to be subtracting 2 from the sequence, and the first term is 11. Once again, let's find and. A sub 1 is equal to 11. N, we don't know, so we leave it as the question mark. D is the common difference. We are subtracting 2 each time. Plug them into our formula like we did over here. So a sub n is equal to the first term in the sequence, 11, plus, in parentheses, n minus 1, times the common difference, negative 2. And we're going to follow the same process we did over here. Distribute and evaluate. So let's distribute the negative 2 throughout the entire set of parentheses. It'll leave us with 11. Negative 2 times n is negative 2n. Negative 2 times negative 1 is a positive 2. Combine like terms. Negative 2n doesn't have anything else to combine with, so we'll leave it as negative 2n. 11 plus 2 gives us 13. Okay? We have 2 more examples today, very similar to those ones. Let's go ahead and continue this process. If you'd like to pause the video and try this one out on your own, go for it. Okay, now once again here, we're going to be looking for an in this whole process. A sub 1 is the first term in the sequence, 27. N is the term that we do not know, so we'll leave it as a question mark. D, we are going to know that it is a minus 19 every time, so we're going to have negative 19 for our common difference. So plug them into our formula here. A sub n is equal to a sub 1, 27, plus in parentheses n minus 1, we still don't know what n is, so we'll leave it as n minus 1, times the common difference, negative 19. Okay? As we did before, we're going to distribute the negative 19 throughout the entire set of parentheses. 27, negative 19 times n, negative 19n. Negative 1 times negative 19, positive 19. And now combine our like terms. There's only one thing with the n, so we'll leave it as negative 19n. Combine the 27 and 19 together to give us a positive 46. Now we leave our sequence here being negative 19n plus 46. Okay? I'll leave this last one here blank for you if you want to try this one out on your own. Okay? Maybe put plus or minus some number in right here and fill in your first term with whatever you want and go about the same process. Okay? Because these are all the exact same processes. All right? Now, if we were asked in this problem to find, let's say, 4 different values for A, okay, 4 different terms in this sequence, no matter what they are, like the 48th term, the 96th term, the 150th term, or the 300th term, we could easily just take 48, plug it in for n, and calculate that on our regular calculator. Now, what we also can do is use the Desmos calculator, okay? So if we're using Desmos here, okay, step 1 is we need a table, okay? Step 1 is we need a table. Step 2, we would need to fill in our table. Now, normally, we would have x1, y1 at the top of the table, or normally, if we had a formula that involved x, we would have x and our equation. But the problem is, people are going to see this and think, I can't use this because it doesn't have x. In order to use this table, what we need to do is, instead of this being an x column, we're going to go ahead and let it be an n column. And then we're going to plug in negative 19n plus 46. Okay, so now this table is going to be solved for n rather than before it would be solved for x. All we would need to do is just plug in 48, 96, 150, and 300. And when we do that, you're going to end up seeing the values, or your y values, the term of the sequence, pop up. So I know you can't see my screen right now, but all I'm doing right now is getting my table, putting n in for the first column, putting negative 19n plus 46 for the second column, and I'm typing 48, 96, 150, and 300 in for those values. In which case, those values ended up being, for the 48th term, that term was negative 866. For the 96th term, that was negative 1,778. For the 150th term, that was negative 2,804. And for the 300th term, that was negative 5,654. Once again, all we did right there was go onto the Desmos calculator, select the table, make these our headings, so instead of x's, we're going to use n's, and just type in 48, it popped this up. 96 was this one, 150, and 300. So if they were asking for those, we could quickly find those. But if we didn't have the Desmos calculator, we could still plug in 48, times it by negative 19, add 46 to it to get this, and repeat the process for the other 3 terms. That will wrap up our discussion on arithmetic sequences here. Once again, make sure if you haven't to complete the assignments that we have been issuing with these. And as always, if you have any questions, send me an email.